Hello, this is number 8 on the practice final. It's dealing with the Laplace transform and an interconnection of continuous time LTI systems. We've been given the impulse response h1 of t and the system's response yt of x of t is the unit step. So part A asks us to find h2 of t. So first we want to find the Laplace transform of y of t. So let's write it. Y of t equals minus 1/2 e minus 2t ut. I took the liberty of getting the relevant Laplace transform for us. It's right here. So we're going to apply that. Y of s equals minus 1/2. S alpha here is 2. And plus 1/2. Alpha here is going to be minus 2. For this bit, we know that the real part of s must be greater than minus 2. Sorry, I wrote alpha. And the real part of s here must be greater than plus 2. So we can combine these two conditions and we can write that y of s, the region of convergence for it, is going to be the real part of s must be greater than 2, because this one right here converges for all values greater than minus 2, and this converges for all values greater than plus 2. So the summation of them can only converge for values of s greater than 2. Otherwise, if we were for values less than 2, this bit wouldn't be converging, so y of s wouldn't be converging. Okay, now we can go ahead and write the Laplace transform for x of t when it equals u of t is just going to equal 1 over s, and this will converge for values of real part of s greater than 0. Now we can write h of s equals y of s divided by x of s. That will be equal to we can combine these, we'll get this 1 over s, the s will come up into the numerator. Okay, so now we can simplify this. Let's write it explicitly so everyone knows what we're doing. Because the tricky part of these problems is the algebra and getting it down correctly. So we'll factor out the 1/2, and we'll take this s, bring it out front. This negative sign goes in here, minus s, plus 2, plus s, because we brought the 1/2 out here, plus 2, s plus 2, s minus 2, these cancel, this is 4, 4 divided by 2 is just going to be 2, the s right here stays, 2s, s plus 2, s minus 2, the region of convergence for y of s was s greater than 2, the region of convergence for x was s greater than 0, so our region of convergence for h of s is going to be real part of s is greater than 2. Okay, so these systems are in parallel, so this would be h1 of s plus h2 of s equals h of s. So let's go back down. They gave us h1 of t. We know h1 of t is equal to e minus 2t ut, so h1 of s, using the same transform as before, is going to be 1 over s. Alpha here is 2. This will converge for values where the real part of s is greater than minus 2. So now we can write, we're trying to find h2 of s, so h2 of s equals h of s minus h1 of s. H of s was 2s, s plus 2, s minus 2, minus h1 of s. Okay, we can simplify this. h2 of s we'll multiply by a factor of s minus 2 over s minus 2 here, so that would look like this. That way we get the common denominator, so we get 2s minus s minus 2 from here. This can be simplified. 2s minus s is 1s plus 2 so these cancel. The region of convergence for h2 of s is going to be s greater than 2 because the region of convergence for h of s was s greater than 2, and the region of convergence for h1 of s was s greater than minus 2, so we can only say that h2 of s converges for values of s greater than 2, using logic similar to what we used earlier. So Okay, so it originally asked us to find h2 of t, so we can use the same transform we've been using, just in reverse. So that will give us e 2t times ut, and that's because so alpha here was minus 2, so we get plus 2 here. And that's a lowercase t, sorry. Okay, that's A. Now it asks us to find the overall impulse response. So the overall impulse response will be h of t equals h1 of t plus h2 of t. h1 of t was given, it's equal to we found h2 of t in part A, it's here. That's B. So now it asks us to determine if the system is stable. We can say that the region of convergence for h of s was for the real part of s greater than 2, so in order for it to be stable, it has to include the j omega axis right here. Ours did not, so it's not stable, it's unstable. I suggest you write that definition down on your cheat sheet. The next one wanted to know if the continuous time Fourier transform exists for h of t. It does not, because the region of convergence for s, again, is the real part of s greater than 2, which is graphed here, doesn't contain the j omega axis, and it needs to contain the j omega axis for the continuous time Fourier transform to exist. So again, write that definition down on your cheat sheet. This is number 8. I'll see you in the next problem.